Hello, in this presentation, we want to show you how we can customize CYME software to be able to use it as the easiest way. First, we want to customize menu of the CYME. We go to toolbar. We want to remove all the menu that are not necessary. For example, contour profile is for distribution, we remove it. Zoom, of course, there is two zoom, I will remove it. Okay, tooltip layer, okay, we don't care about because there is another access to have the tooltip. Drawing tools, I remove it. Then database, we don't use database in this format in industrial, so I remove it. Then simulation, we needed display, we needed advanced editor tools for distribution networks, we remove it. Editor tool also for distribution network, we remove it. Load model for distribution networks, we remove it. And also there is find, so we remove also find. So the menus and the toolbars will be the simplest available. So what we have here is what exactly is necessary for industrial networks modeling. Here also on the left side there is database, there is network, delta, symbols, display, abnormal conditions, switch, and equipment search. So again, we want to customize it and put it as the simplest solution. So go to View, Explorer bar, and remove database. Okay, equipment search, switching monitoring. Okay, and here abnormal condition also is for distribution in industrial. We can see also this on the reports, but we can keep it. We can keep it. Okay. So what we need, this is the simplest. So we have network, detail view, symbol bar, display, and abnormal condition. Okay. Another setting you have to do at first is preferences. In preferences, first go to editor. When you go to editor, click on No for the display selection property to allow when adding a section or a device. In this case, if you click on Yes for any equipment that you add to the network, it will show you the menu and it will be time consuming. Okay. Another tab. Okay. We have to click. Then if you open a new network, I put a new network, so I will put it new. Okay, you will see that there is no database inside of the software. We have some database that we can import it, for example, for motors from CYME database, but for training we don't want to use this. So what we want to do, we have a template database, and this is template database, CYME typical database. We use it for training and for the users that want to start working with CYME. So we open it, and then go to symbol bar. In symbol bar, there is general equipment, there are sources, switching and protections, harmonics, okay, and power electronics. But we don't need all of these, of course, all of this equipment. So I want to customize it. So right click and click on add a group. So add a group, put it as a customize. So it will be customized group. And for customized group, I select transformer, only two winding transformer right now, and click on default, because I don't want to see all of these database. For switch and for breaker, also we need breaker, and LV circuit breaker, no, I don't need right now. Oh, maybe I need one of these. For switch also, that's it. and then line and cables for cables. Okay, again, click on default to see only the default value, and then overhead line and motor and load, spark load and induction motor, also put it in the default. That's it. And what else? We have nested view, we have horizontal bus, vertical bus, and what else do we have? We have sources, synchronous generator, okay, and equivalent of the source. And let's see if we need any more parameters, any more equipments. Maybe we need a capacitor, shunt capacitor. Okay, I put it on default. Then power electronic, I need VFD, only VFD. Okay, so click on VFD. That's it. So already I customize my menu, customize group, and I want to remove other groups. So I remove the groups that I don't need it. Remove group of harmonic, remove group of switching, and remove group of source. But I keep general, maybe I need some parameters. So right now I have a customized group that includes all the parameters that I need. Also I can change, okay, vertical bus bar and horizontal bus bar. Okay, I remove it. Okay, put it as the first item. Okay, right now I have vertical, horizontal bus bar, two winding transformer, breaker, LV circuit breaker, switch, shunt capacitor, cable, overhead line balance, spot load, induction motor, synchronous generator, equivalent source, VFD, and nested view. Okay, right now if I go to, because this file is a template database including the minimum database or typical database. If I go to source, I can see I have 3 typical source. If I go to regulator, I have some typical regulators. If I go to transformer, for any 2 winding, 3 winding, there is some typical transformer can be used for example. For generator, synchronous generator, also typical synchronous generator. If you go to motors, induction motor, there is some induction motors. Of course, there is a database we can add from library, but there is some typical data that we use it for training. And if you go to, for example, all the equipment, we have some examples here and some typical data. For conductor, for cables also, there is a LV and MV cables as a typical data, and overhead lines. Overhead lines, we have typical data of overhead lines. So, over capacitor, for example, for VFD, even for VFD, we have typical value of LV VFDs. Okay, so right now I'm going to draw a network and do the analysis. So right now I'm very simple. I draw the network. Here I click on bus, drag and drop it here. Then here there is a source. Okay, put source here and connect source here. Then there is another bus bar here, and then there is a generator. So there is a synchronous generator. I connect it. See how nice. Okay, so I connect it here. Then there is another bus bar, so I put another bus bar here. Another bus bar also here. So very simple. I am drawing the network. 2 winding transformer between the source and there is a cable. So there is a cable. I put it. Also, you can do something like this. Put it and then connect it. So it's possible. Then I put a transformer between these two bus bars and put another bus bar. Okay, so in this case my network is going to be complete. Then I put another bus bar here. That's it. And then I put another induction motor. So I connect the induction motor to this bus bar, and I put a cable outgoing of this, and then I wanna have a subnet for here. I put another cable here, and then an induction motor. That's it. I extend this bus bar and add another induction motor. Okay, and here I have to put a cable to connect this to this bus bar. Okay, so if connection is not correct, I change it. So I will have a nice connection. Okay, right now I want to add a subnet for come down. There is a nested view here. In this nested view, I put it as a, for example, MCC. There's a MCC number 1. And then, okay, I change it. Change the size of this MCC. Okay. If you go to MCC, I put a bus bar. And there's the LV circuit breaker that can be connected at the incoming of this bus bar. So here I put it as a connector, create a connection port. Okay, I change it, the location, and then connect this cable to this connector. So means that this connection has been done by this connector. So right now I put a load, spot load, 2 spot load, 1 here and another one. Oh, I forget to put cable. So what I do, I drag and drop cable here. So I have cables of this to load. Also, I put three induction, 1, 2, and 3 induction motor, and then I add cable. So very nice, I can connect all this equipment. The graphic is very nice. That's it. So our network is almost complete. When I come back to this network here, you can see the network complete, and you can see the subnetwork here. Also, I want to see an overview map, and then here in overview map, I can see the total network. For big network is a very nice item. Right now, I want to put the parameter, electrical parameter here. Just what I have to do is that I double click on equipment and relate the database. I relate the database 33, and you can see the 33 kilovolt capacity, everything. So these parameters comes to our equipment. For transformer, it's a 33 by 11 kilovolt and 30 MVI. So I double click. For the ID of 2-winding transformer, I click and select the proper database. Then there is a load tap changer. Right now I want to put it off, and I want to remove the control. And the voltage also I put it on 100%. Or there's another solution, I put it on fixed tap. So I put it in fixed tap. That's it. Another transformer is here. So right now it's 33 kilovolt. Here is 11 kilovolt. This should be 11 by 0.4. So I click, it relate to the database. There is a transformer. I think this transformer 11 by 413 is better. And then I again go to load tap changer, remove it, or I can put it as a fixed tap. So before removing this, I have to load tap changer, put the setting of the tab on the 100%, and then okay, at the end I put it as a fixed tap. That's it. So right now the voltage of here is 0.4. There is a generator here. Of course, there's a diesel generator. I selected as a typical data 600. The parameters come here. Power factor 80%. And then there's a cable. Okay, I select the cable here around 300, the voltage is 1 kilovolt and the size 300. So I have 300 and I put it as a 2. So the nominal rating it will be 900. Then there is another cable here. I select. I think I forgot to put the length of this cable. Length of this cable is around 200 meters. So I have another cable. I open. I select the cable. It should be around 400 millimeters square 2. And then number of this cable are 2. And then the length of this cable is 150. So another cable, of course, is here. This cable is a 240 millimeters square. So I select here 240 millimeters square 2. Number of cable in parallel is 2, and the length of this cable is 250 meter. And of course, I think we have everything for this cable. Okay. Then there is a motor, induction motor. Induction motor of this is 225 kilowatt. So we go to database and select 225 kilowatt. Okay, the data, you can see the data of the motor. We come back to this data later. Okay, and then there is another motor here. This motor, of course, there is 11 kilovolt motor. I come to 11 kilovolt motor, 5,000, around 5,000 horsepower. And this is another motor. I select it, and this is 11 kilovolt, and this is 12,000 horsepower. Okay, that's it. So I have to go to subnetwork. Go to subnetwork, and there is a breaker. In this breaker, okay, I select it here. The current should be around 100. Okay, I selected 100. And then here there is some load. Okay, this load, when it's open, you can see that this is by phase, but our network is balanced. So I go to preferences, select on configuration, and select here that all the loads with the balance. So my network will be balanced. Okay, then again open it and put it and select it as a kilowatt and power factor. And kilowatt and power factor, put it 15. And the power factor, of course, it will be 80, 85, something like this. The next load, I put it as a, again, kilowatt and power factor. We can put it kilowatt ampere power factor, and kilowatt and power factor. Okay, kilowatt and power factor, put it 20, and put it 80%. That's it. There is load type that we talk about this later. So here, there is motors. So there are 3 motors. I select all 3, right click, and click on group properties, then unselect, go to motors and select. This motor should be 39. So I go to 39 kilowatt, power factor 91, and connect it. But this motor, one of these motor is a standby. So here, one of these motor will be open. So right click and can click it, click on off. So one of these motor are a standby and will not be run. Okay. For other, I want to have cables. Right click, group property, and just select the cables. So I just select the cables here, and here I put the cables. The length of all cables will be around 100. So I put it for the length all 100, and for the cables I put all the cables here 70 millimeters square. Okay, and click on apply, and then I want to save it. I will not save it in this file. I will save it in another case. So I save it, and then I select the path. I put it as case study 001, any name, no problem. But what is important here, you have to click on all the equipment and check on all the items. So it's very important. And do not save the modification. It's not necessary. There is some feature we'll talk about this later. Okay, so I did it. So right now we have length of all this cable 100. Okay, and the size of all this cable is in 50. So very simple. I did this modeling. So right now, if we didn't do any mistake, we could have load flow. I click on load flow. Newton-Raphson method, tolerance should be at least 0.0001 to have the best accuracy. And then, okay, and run it. Okay, load flow will not be run. So there is some problem. Let me see what's the problem here. Maybe there is some load, some cables, maybe, oh, here, the length of this cable is too high. Length of this cable, okay, let me see. Length of this cable is around 500 meter. And then you can see this cable is 12 kilovolt cable, and the size 300, it should be 1 core, okay, and number of cable in parallel will be 2. So we'll fix it, then again run it. So when we run it, you can see the result. I select power flow, result here, and I can see the voltages. Voltage up here is 1.21, voltage up here is 0.9, voltage up here is 0.96, voltage up here. Okay, let me see. And also in the next movie, tutorial movie, we will talk about customization. Okay, here I sense the voltage up here, and then when I go here, I can see that we have a problem. This has overload because already there is a abnormal condition. I want to show the abnormal condition. Also, the abnormal condition can be shown here. So when you go here and see LV circuit breaker has abnormal condition, click on it, you can see it on the network. Okay, let me remove this. Also, when you want to see this Explorer bar, you can click and unclick. So in this case, you can see a big network. Of course, I will go to overview map to see all this parameter. So right now, we model a network. Simple, in less than 10 minutes, we model a network. We put the parameters and we draw everything and run it, and the result, you can see the result on one line diagram. We come back for the next tutorial movies. Thank you, and we'll see you on the next presentation.